Welcome friends. In this module, we'll be looking at RMI. At the end of this module, you should be able to create an application in Java, which will be a client-server application, where we will be using the RMI technology. So let's start with, what is RMI? RMI stands for Remote Method Invocation. So what is the impression it gives? Invoking methods from a remote place? Yes, it's more about developing objects on which methods can be invoked from a remote place. It's not that you can invoke methods from a remote place on any kind of object. So RMI is more about how do we develop objects in Java for which methods can be invoked from a remote place. Okay, to achieve this invocation of methods from a remote place on any object. Okay, let's call this kind of an object as a remote object. So if we want to achieve this method invocation on a remote object, what we would need is, it needs this kind of an object would not be working in as a standalone thing. It needs to have some kind of helper objects available for it. Fine. For example, in case of RMI, for a remote object on which we would like a method to be invoked, let's assume we have a host server on which such a remote object is available. Fine. So for this object, we would also need two corresponding helper objects. One which would be on the machine of the remote object and other on the machine of the invoker. The object on the invoker's machine is known as the stub, and the object which is available on the remote machine, that is the machine where we have the remote object, we'll call it as a skeleton. So a remote object, for it to work, takes help of two other objects which are known as the stub and the skeleton objects. How does it work? Let's see. So if we want to achieve this method invocation, a remote method invocation from any machine, the final arrangement which would be required would be, yes, we'll have one host machine, or let's call it as the server machine, because our remote object here is having methods which we can consider as services being available to others. So let's call this machine as a server machine. And so we have a server machine on which we got a remote object. We would need to have ultimately another object of the skeleton, which would be having a reference to the remote object. So this is the arrangement on the server side. On the client side, the invoker's machine, that is, on the client side, what will be needed is, yes, the client who wants to invoke the method would need an object of the stub, which is having connected, which should have a connection with the skeleton. So it's like we got a connection between the stub and the skeleton. There is a protocol which works between the stub and the skeleton, and the skeleton is in turn on the same machine as the remote object and would be able to invoke a method on the remote object. Fine. So one thing here, what is needed here is, the stub here should have the same set of methods as what is available in the remote object. Fine. Yes, we'll see how exactly this is going to be achieved, but yes, we'll at this moment what we need to know is, yes, whatever are the methods in the remote object which are available as service for method invocation from a remote place, the same set of methods would be available on the stub object. So client, the end user, is going to have locally an object of stub on which he would like to invoke a method. He invokes the method which he ultimately wants it to be invoked on the remote object. So the way things would happen, the things would proceed here is something like this. Whenever the invoker, the client, invokes a method on the stub, the stub has to do certain things. The stub will have to marshal, the stub will have to look at the parameters which have been passed as method invocation on the stub. All these parameter values will need to be sent across to the skeleton. Fine. This process of sending across the parameter values by a stub to the skeleton, or sending parameters or any values or any objects across on the network, is known as marshalling here. So here what is being done by stub is, initially when someone invokes a method on the stub would marshal the parameters and send it to the skeleton. On the other side, the skeleton receives the parameters, or we call it as it unmarshals the parameters. Fine. Understand, this is going to be achieved on a TCP IP connection. Fine. This connection, the connection between the stub and skeleton, is a TCP IP, a stream based connection. Fine. So a few requirements: anything, whatever is being marshaled, needs to be a serializable thing. So of course, so what is the requirement here? We would not be able to invoke methods with any kind of parameters. The methods on which you are, the methods whenever they are being invoked, the parameters, the objects which you send, we need to ensure that they are serializable. Unless they are serializable, they can't be marshaled on a stream based connection. Fine. So that's one requirement, keep it in mind. Fine. Now once the marshalling of parameters is done and unmarshalling is done by the skeleton would in turn, as a next step, it would in turn, on receiving the parameters, would in turn invoke the method on the actual remote object. Fine. After invoking the method would return some value, or it might throw an exception. If it returns a value, yes, what will be done by the skeleton on receiving the value from the method? Whatever is the return value of the method, the skeleton is then going to send the returned value back to the stub. This is again, so what is being done by the skeleton here is, the skeleton is marshalling the return value back to the stub. The stub, on receiving, the stub unmarshals the return value, and then the stub in turn returns the same value, whatever it has unmarshaled, back to the invoker. So that way, whatever object was returned by the remote object, method invocation, the remote object by the skeleton, the same object is being returned back to the stub, to the invoker by the stub. Fine. So this is how the ultimate arrangement would be. So in this arrangement, yes, as we can see here in this diagram, we can see that we have a host machine having a remote object, we have a skeleton on that same machine. On the other side here we got a stub object, fine, and the method invocation taking place, marshalling of parameters, unmarshalling of parameter by the skeleton, invocation of method. After the invocation is over, return value is back, marshaled back to the stub, and the stub in turn returns the same value, fine, whatever has been unmarshaled. Okay, one thing we can see here is the unmarshaled value, it's nothing but a copy of the original object. Fine, it's not the same object as such. Yes, it's just a copy. Fine, keep that in mind. Fine, we'll see something related to that, because this becomes almost a pass-by value. It's a case of pass-by value, whereas for reference type, we normally think, in normal method invocations, we think of it as a pass-by reference. Okay, fine. Now proceeding further, so yes, this is what the arrangement is what we want to have ultimately, so that we can have method invocations taking place. So let's see, how do we go about creating such a thing? Fine. So our idea is to have some kind of remote objects being developed, where the remote object has methods which are providing some kind of services, and these must become invocable. Fine. And for this, yes, we need the stub and the skeleton objects to be available. So the steps needed for developing such an object. So our aim here is to develop such an object. Fine. You can consider, for example, we can take an example from some kind of a banking application. So in a banking application, maybe you might have some object providing services for the bank. Let's call it as a bank itself. So we got a remote object of a bank. Okay, what kind of services will it offer? Okay, we'll need a service called open an account. So we'll have a method called open account. The parameters for that, okay, it might take the type of account you want to open, the name of the account holder, the opening balance which you would like to have. Fine. So that should be sufficient for the method. Fine. But then in turn, what does the method do? This the service called open account, what will it do? Oh, it would in turn be returning the account number. Fine. So when we do, so the implementation on the remote object may be resulting in, when we do such a thing, it might result in creation of an account object on the remote object, on the server side, and then this remote object is being managed within the server only. What it might return back is only the account number which you have to use for in your all subsequent invocations. Fine. Sometimes we might like to have some method like this. Oh, I would like to have the access to that object, that account object. So maybe we have a method called get account also, which requires an account number. So given an account number, we would like to get the account object. So let's assume we got two such methods at least. There will be a lot of other methods, like we'll have methods called deposit, which requires an account number and the amount to be deposited. We'll have a withdrawal method. Fine. Like this, yes, we might have a method to inquire about the balance. Fine. So we might add a lot of methods, most of them involving account number. Fine. We pass account number and it gives us information, or we pass account number and amount and maybe there's an updation which takes place. Okay, fine. So we got our requirement is, yes, we want to have such an object available on a machine where it works, and whenever we have any method invocation required, fine, any of these methods whatever we are providing in the bank, that should be available for remote invocation. Okay, so we got a set of methods which we have identified here now. Fine. Now let's look at the steps required for creating a remote object which works over RMI. So the first requirement here, yes, the first step would be to identify the methods, which we have already done in this case. Okay, so once you have identified what methods should be there in our remote invocation, fine, we need to define an interface. The steps here required here are, yes, you must have an interface whatever is your type you need. For example, in this case, we might start by saying, oh, we need to have an interface called bank, and this interface, whatever interface we are defining, which would have all these set of methods, must extend from an interface called remote. Yes, we have an interface called remote belonging to the java.rmi package. Okay, so now once we have the step one was identifying the methods and defining an interface. Fine, this is the interface for the remote type which we would like to have. So in our example here, yes, we were going for a remote type called bank containing methods like open account, a method called get account, a method called deposit, a method called withdraw, and so on. Fine. So yes, that's put in the interface. Another requirement in this step itself, when we define this interface, one thing was, yes, this interface must extend from an interface called remote. Okay, this interface remote is simply a marker interface. So there's no new methods in this interface. So don't worry about any additional methods which would be required for anyone to implement here. It's only the remote methods which we identified which would ultimately be required to be implemented by the developer here. Okay, so remote is simply a marker interface, that's fine. Now, so step one, okay, one more point. All the methods here. See, this is what this set of methods is the methods available for remote invocation. So they will be available on the remote object. Another point, they are also going to be available on the stub. Fine. So it's nothing but this interface is a common interface implemented by both the stub object as well as the remote object. Fine. So that's how the invocation would be taking place. Fine. So that's how the all methods, same methods, whatever methods on the remote object, same methods are going to be available on the stub. Now one thing, we will have the actual implementation available on the remote object, whereas there is going to be an implementation on the stub which is going to do the marshalling. It's like you invoke a method, it has to do the marshalling of the parameters. It has to do the marshalling, passing all, there's a protocol between the stub and the skeleton which is taking place here. In order to marshal and unmarshal, it has to unmarshal, it has to identify whether there's a return value which has come or there is a exception which has come, okay, fine. So all those things are fine. So there is a protocol between the stub and the skeleton which is also involved here. So one thing, the method implementation for the stub can result in some kind of an exceptions because of the protocol failure. It might be a network failure or any other, but the protocol between the stub and the skeleton can fail. And this failure is what we call as remote exception. The failure here is resulting in a, so there is a possibility of the method implementation by the stub throwing a remote exception. And therefore, when we define our interface in step 1, all the methods, so it's the step 1 interface extends from remote, and all the methods here must have throws remote exception. Of course, you can always have your own exceptions also in the throws clause. So for example, okay, if you feel that yes, the bank application, if someone is trying a negative value for a deposit or a withdrawal, or I might have my own exception class called negative amount exception. In that case, include that also in your throws clause. Okay, so for example, in this case, you are saying, okay, my deposit method, which takes account number and the amount as a parameter, has a throws for a negative amount exception as well as remote exception. Remote exception is a must for all the methods here, because these are the methods which are going to be also implemented on the stub, where the possibility of failure is always there, and that failure is a remote exception. So step 1, as a developer, yes, developing an interface. So in our case here, let's say we put our public interface, bank extends from remote, having a few methods like this. Each of these methods, as you can see here, contains a throws remote exception. Fine. Okay, so step 1 is fine. So we identified methods and we have an interface. Next step. The second step here is to identify, is to now write our own implementation of the methods which are going to be available as for remote invocation. These are nothing but our services here. Fine. So our remote object is going to have an implementation of the various methods here. Fine. So whatever methods we identified in step 1, each of them requires an implementation. So we need to write an implementation class. So our second step is define a class which implements the interface which we have defined in our step 1. So in step 1 here we define an interface called bank. So let's say we are going to define a class called bank IMPL for the implementation of the bank interface. Fine. So we can go for such a class. But one more requirement here. What are the methods which are invocable on the stub? Is it only the methods which we have identified in step 1? Oh, we also have all the methods from the object class which are always invocable. How should the methods of the object class be implemented in the remote object? Oh, there will be some special requirements for that. Fine. So yes, those methods, for example, wait, notify, or those kind of methods, how will they be treated when they are invoked from across the network as a remote method invocation? If anyone tries of any of those methods, how should those be handled in order to take care of such things? What we normally have to do is, we have a ready-made class which contains the implementations of these methods from the object class, methods of the object class for remote invocation, and these are available in the class called unicast remote object. This is part of the java.rmi.server package, the unicast remote object. So in the second step, what we normally will be doing is, yes, we'll be defining an implementation class fine, which implements the interface of step 1, but it also has to be extending from the class called unicast remote objects. So here we would define, for example, public class bank IMPL extends from unicast remote object and implements bank. Fine. Another point here, the constructor for this class. Yes, we will have our own implementation. For example, in this case, we might write some implementation for bank IMPL where we will be managing all the account objects. So when someone says open account, yes, we'll have to write our own implementations. So write the implementation the way we normally write our implementations. Fine. That is having, okay, in this case, for example, you might be using a map to manage all the account objects as they are being created. In a map, account number wise, all the account objects are being managed. Fine. All those things can be taken care. That's fine. So you may have your own ways of implementing these methods. So don't worry about how do I implement these methods. Write the implementations the way we normally write any implementation, even if it was a local application. Fine. So once we have done this, a few things to take care here. We will need a constructor. Fine. We'll need to define at least a constructor, and one important thing, since we will have a constructor here, the constructor is going to invoke the constructor superclass, in which case, in this case here, the superclass is unicast remote object, and therefore the constructor here would also, the constructor of the unicast remote object has a throws remote exception, and therefore when you define this in second step, when you define your class which extends from the unicast remote object, implements the interface of step 1, it also needs to include a constructor which has a throws remote exception. So yes, creation of such an object would require a throws remote exception also. Fine. So fine. So step 2, yes, you are writing your implementation class. It contains all the implementation items. Fine. So once all the implementation of all the methods is done, you have used appropriate structures, you have your implementation which is ready. Yes, you're ready, you're almost ready, because yes, now what you have done is you have done your job of writing the implementation of the services, the methods, whatever you want to make available. Fine. Next step, let's see. Now there were a few things which were there were things which were done differently in the older versions and slightly different in the newer versions of Java related to RMI. It's about the stub and the skeleton, creation of the stub and the skeleton classes. Yes, initially it used to be like this. When Java 1.0 was there, RMI introduced at that time, or rather 1.1, yes, RMI at that time was having a tool, we still have that tool available. There is one tool called RMIC. We don't have to actually implement those, we don't have to write our, we don't need to write the full classes related to the stub and the skeleton here. Because if you look at those stub and skeleton, they are almost a mechanical kind of a program. The kind of programs which can always be derived from the remote class. If someone has written a remote implementation class for the remote object, by looking at it, it's a mechanical job which can be done, which can be done for deriving the stub and the skeleton classes. So what we had was, we have a tool called RMIC, which is part of the JDK. So we have this tool called RMIC, which can always be used for generating the stub and the skeleton classes from the remote class. So step 2, we defined our class, we have our class file available, it's been compiled, and then in the step 3, we can do this job of creating the stub and the skeleton classes. Defining the stub and to create these stub and skeleton classes, we don't have to write any code, we just simply use the tool called RMIC. RMIC in earlier versions was generating the stub and skeleton, two separate classes. Later, from 1.2, Java 1.2, they had identified that it's better to have just the stub created, the skeleton part can be included within that itself. Fine. We don't need to have two separate classes. So earlier, for example, if we had this class called bank IMPL and if we ran RMIC, it would create two class files from it. It would actually use this class file for bank IMPL, and from bank IMPL derive two separate class files for which the steps were a compilation. It would actually be doing the generation of the Java files first. It would create the Java files, then compile them, get the class files, and then it would get rid of the Java files which are temporarily created for the generation of the class files. And then yes, the end result was two class files. So it would be bank IMPL underscore stub.class and bank IMPL underscore scale.class. Those kind of two classes used to be generated. But then in 1.2 they identified and they said, okay, it should be possible for someone not to go by two separate class files managing more files. Rather than that, let's just manage a single class file called, so we should be generating only the stub class. So this can be done by using, when you use RMIC command, they added one option, one command line argument called minus v1.2. So if you say minus v1.2 RMIC and say minus v1.2, then it would generate a single class file. If you use minus v1.1, it would generate two class files, the stub and skeleton separately. Fine. And then later on, so the default, like if you don't specify minus v1.1 or minus v1.2, the default was to use generate two class files. That used to be the default till we had Java 1.5. From Java 1.5, the switch has changed. That is, the default value has changed. It's like by default, it would generate only the stub. Okay, so just remember those friends. So whichever version you are using, accordingly, you should be aware. If you use RMIC without any minus v option, minus v1.1 or minus v1.2, fine. You will be getting two class files or one class file depending on which version of JDK you are using. Fine. So better is to specify minus v1.1 or 1.2 according to what you feel like comfortable. Okay, you want stub and skeleton separate, or you might like to have only the stub single file, which is the stub file. Okay, and fine. So now step 3 was to generate the stub and skeleton classes. Fine. Once we generated the stub and skeleton, or maybe seeing only the stub part, so these files together, that is the remote implementation class, the interface class file, and the stub or skeleton, the combination of stub and skeleton. Fine. All of these together actually are needed for the remote method invocation. That means my bank service can work for me if I have these files available to me. All these class files would be needed. It's not a single class file here. Okay, so these together are making a remote type called bank for me. In our example here, yes, we have used bank as an example. So bank is my remote type. Fine, that interface type. Interface, we selected interface name as bank. Class name which selected was bank IMPL. Bank is actually the data type here, the remote type here. Okay, so bank can now be used. Okay, it's now become usable. Now, in order to use this, yes, it's all whatever we have done is all only development, and we have generated some class files which could now be which would now make our, it's like we got our remote object being available for use. Fine. That is, we wanted to achieve RMI. Yes, it is now achievable, but we need to write the code which can actually do all the job now. Okay, what will be the things? Yes, what we need here is, we need some application which would create the object of the remote type, and then, oh, how will the client be able to access that object? There is an application, yes, there's one Java application which creates a remote object, but then how will any client from a different machine, how will it identify that object? How will it be able to reach that object? So in order to be able to reach a particular object, yes, the initial part which is needed on the server side is, yes, we do need some kind of a service which can make the remote object which we have created, which is being created by an application, to be available and known to the client by using some kind of a URL. Okay, and this is for This kind of a service is available as part of the Java runtime. The Java runtime contains one service called rmiregistry. It's a naming service where we can register, basically with rmiregistry we can register a name, fine, and we can assign a remote object some kind of a name, a remote name, and then that remote object can be assigned to it, fine. So what we can achieve, what we do, the next step what we normally do here is, yes, assign a name, identify a name, and have an object and have it registered with rmiregistry. Okay, but before that, yes, rmiregistry needs to be started here. So we'll have an rmiregistry running. Only then the things, only then the client will be able to ever use it. Also, the creation of object which is being done by the application. Some application is going to create the remote object, the object of the bank IMPL, that needs to be registered with the rmiregistry. So the application on the server side, assuming that rmiregistry is working, would have the code to create the object and register with the rmiregistry. Oh, here it needs to interact with the rmiregistry service. Fine. So we got interaction of our server application with the rmiregistry. In it's the requirement here is to be able to register the object with rmiregistry. Fine. Register, unregister, various kinds of interactions would be needed by the server side application related to the remote object. Similarly, for a client also, if you look at a client, even client needs to interact with the same rmiregistry in order to find out information related to the remote object and be able to connect with the, be able to create a stub which gets connected to the skeleton. The original picture which we wanted, we have a stub, we got a skeleton, and we got the remote object. Only then the things start working. Okay, so in order to achieve this, let's see what is going to happen here. So what we need here is rmiregistry would need to be started first, and then okay, we need interaction with the rmiregistry. Now for interaction with the rmiregistry, we got a class which is part of the java.rmi package. We got a class called naming. The naming class contains methods which can be used by a server for interaction with rmiregistry. Fine. Naming class has simply 5 static methods. There are only 5 static methods in the naming class. Fine. What would be initially used by the server side, the server side application, in order to create a, in order to register is, yes, it wants to register. So first step normally on the server side would be the server side application create the object of remote, the implementation class, and then register. How does it register? For that, we have the static method in the naming class called bind. Bind is nothing but a method by which, where we pass 2 parameters, a name, the name by which we would like to register, and the remote object which we have created. Those two will be passed as parameter to the bind method. So it gets, so it's like registering our object. For example, in this case, someone says, oh, I have created a bank implementation object, so let me use the bind method. So in the bind method, I might pass first parameter string as HDFC, and then, so that's the name by which I would identify this object and put the object there. Fine. So that's how it is being made available. It's being known to rmiregistry by a name called HDFC here in this case. Okay, so fine, bind is one method. Another method in naming is, okay, now one more point here. When someone says bind and he's using a name like HDFC name is being used. Now if someone else also on that same machine tries a bind method and gives the same name, that is, the name is HDFC. If there is a name clash, the bind method would fail. So the first parameter, the string which you are using, has to be something which is not already in use. Now many times what would happen is maybe you restart the same application but you use the same name already, and therefore your bind method is going to fail. So instead of using a bind method, we got an alternative method. There's a method called rebind. Instead of using bind as an alternative, we have the method called rebind. In case of rebind, the rebind does not fail if there is a name clash. Instead, if there is a name clash, the original binding which was existing would be removed and the new binding would be in effect. So rebind doesn't fail if there is a name clash, whereas bind method would throw an exception, rebind would not throw an exception if there is just a name clash. Fine. And okay, so two methods we have seen: bind method, we have seen the method called rebind. There's a third method called unbind. So these three methods, unbind is, yes, you just simply give the name which you have used. So some object which was already registered by a particular name can be then unregistered from the RMI registry. So you have bind, rebind, unbind, three methods which are normally used by the server side application. Okay, we got now the next method which we are looking at is the method which is used from the client side. What the client wants? The client wants to get, the client's idea is to be able to connect to the RMI registry, fetch the information about how do I connect with the skeleton object which is on the server side, how do I create a stub on my side. So getting all this information and then creating the stub object which is connected to the skeleton. All these things are achieved in a single method here for the client. The client simply uses a method called lookup. The lookup method has a return type of remote. It's nothing but our remote object which was created. It's nothing, when he says lookup, what the client gets here is nothing but a stub object which would be connected with the server. The parameter to the lookup is a URL. The URL, in this case, for RMI objects, the URL is in the form of, the protocol name would be RMI://host, the host where the server is, where the remote object is available. The host the host machine to which RMI registry you are connecting basically. Fine. It's the same machine as the machine where we have the host. So RMI:// we have the host. Optionally, you can always use the port number. The default port number for RMI registry is 1099. So if my protocol name is RMI:, by default it would be assuming port number as 1099. Only by some chance, if someone wants to try out a different port for RMI registry, so when you start RMI registry, you might have started on a different port. If you have started on a different port, in that case you might also optionally give a colon and a port number, and then slash and the name by which the object has been registered. For example, in our case here, it was registered by the name of HDFC. So the URL here looks like RMI://. You will have your IP address or the host name of the RMI registry / and HDFC. So that's the kind of URL string which will be needed by the client to get the object of stub. And what he gets immediately, so in one step, see, it's just a single step for the client. In one step, what he's got is object of stub, the stub which is already connected. So yes, when we write our code here, we'll have to say bank. Fine, we can write simple code bank because that's an interface type containing all the methods. A variable name like bank could be used, equals naming dot lookup. Parameter is RMI://. Oh, of course, we'll need to do the casting because the return type is remote. So yes, we need to do casting as bank. So cast as bank, naming dot lookup, RMI:// the host name /HDFC, and that's how you can get the object of bank. And once you have this object of bank, you can start invoking the method. So for client now it's one step, and he is now able to invoke any method which is available as part of the interface. So in our interface we defined so many methods. All of these methods are now invocable on the remote object. Fine. So clear. So this is like how we achieve how the client would be able to start his interaction. So server side application, if we are writing a main method, there are two steps he is doing. First step, he is creating the object, and second step, he is registering the object with the RMI registry. Whereas for the client side, single step, he gets the object of stub. and then onwards, yes, remote method invocation can start. The client can then just start invoking methods on the remote object. Server side only 2 steps were needed, but here we had assumed that RMI registry is already working. If RMI registry was not started separately, fine, we would not, that binding method, nothing would work. Fine, you might create an object, but then there's no RMI registry to make the information available to the client. So that was important. Fine. So RMI registry is assumed to have been started on the server side first, and then this application starts. Oh, so each time I start my application, I need to remember that first I need to start RMI registry, and then only I start my application. Oh, do we have some other mechanism? Yes, we have some other ways also. But before going to that other thing, let me just finish off with the methods in the naming. When we were looking at the methods in naming, we saw 3 methods which were used by server. We saw the method called bind, we saw the method called rebind, we saw the method called unbind. 3 methods, 1 method lookup, which is useful for the client, 3 methods for server, 1 method for a client. There is a 5th method here which can be used by both the client as well as the server. This is a method called list. The list method takes a single string as a parameter but returns a string array. It's nothing but you're connecting to a RMI registry and asking the RMI registry to give the names, all the names which have been registered there, or all the registered objects. So on the server side, it's usable by both the server as well as the client. When used by the server, the string which will be passed will be simply an asterisk, the star, the wildcard. So he passes, so naming.list on server side, he passes star as a parameter. What he gets back is a list of all the names by which some remote object has been registered. Whereas for the client, again, even client can use the list method here. So for the client, he uses a list method. When he uses a list method, the parameter which he passes is RMI colons, he uses a URL format. So RMI list, and then he says RMI colon / the host, the URL / now instead of some kind of a name, put the asterisk there, star. So once he gives a wildcard, what is returned as a string array is nothing but all the valid URLs which are available as remote objects, which can be used in lookup by the client. So we get actually the list of the URLs here from the RMI registry. So that's how we can, so that's the 5 methods, static methods of the naming class. These are static methods in the naming class, fine, and anyone could be using it. You don't need to create any objects or anything, fine. So now let's proceed further and look at the other aspect, which is related to how do I manage not to start RMI registry explicitly separately and make it part of my application. So when I start my application, yes, I should be looking for, oh, have I started RMI registry or anything? So we got a few, there's a separate package here which makes this available possible for us. We have a package called java.rmi.registry. As part of this package, there is one interface called registry. This interface again contains the same set of methods, but now these are not static methods, these are instance methods. This contains the same set of methods as we have in the naming class. Those 5 methods which we saw: bind, unbind, rebind, lookup and list. All these 5 methods again available in the interface called registry. It's an interface here. So yes, so and another the useful thing here, what will be useful, we need to get some object of registry somehow. Who will provide us that? So for that, again in the same package, we got a class called locate registry. So if you would like to have your application not to be dependent on starting RMI registry separately, what you could always do is you could use this class called locate registry. Fine. There is a static method in the locate registry called create registry. This method takes parameter as a port number and returns an object of registry. fine, where all the 5 methods would be available. So we got on the server side, the code, now we can have 3 steps instead of 2 steps. First step can be when he creates the object of the remote, that's fine. But now second step, now instead of doing naming.rebind or naming.bind, what he could always do is he could start the array, he can actually reserve that port 1099. So for example, I'll say, okay, locate registry.create registry and pass parameter as 1099, the port number on which I would like to start the registry. So it starts a registry on this port, and therefore there's no need to have a RMI registry started externally separately. If you do this, yes, it will start listening on port 1099, and it's like equivalent of starting an RMI registry. And then the third step could be the registry object returned the previous step. You can do a bind or rebind on that object, and that's how you can actually achieve this, where have your application, server-side application, not dependent on starting RMI registry separately. You can have it started from within your application itself, and that would be the recommended way. Okay, so fine, clear. The steps are clear how to achieve remote method invocation. Okay, fine. There's another topic which is still remaining related to RMI. I'll include. Okay, if you look at that method invocations, the marshalling, the unmarshalling part, coming back to that part. Okay, now if we consider our bank on the remote side, it's managing its own account objects, creating account objects, managing them, and then so a client, what does the client do? The client simply does in the main method of a client, he might simply does a lookup, gets a bank object, and start invoking methods. Now maybe we have provided a method called deposit, we have provided a method called withdraw, where account number is provided and the amount is provided. But we also provided one more method called get account. Now what would happen here? What does this get account method do? If I use the get account method, giving an account number, okay, here it's being marshaled, the account number is being passed to from stub to the skeleton uses it to get the account object. Getting the account object, and then what? Marshalling it back to the account object. Account object is what is returned by the get account method to the skeleton. The skeleton would then be passing it, marshalling it on the TCP/IP connection, and what is received back here by the stub object is a copy, because it has been marshaled on a TCP/IP connection. So it's like he is recreating the object. Of course, it is assumed here that our account class is serializable, otherwise this would not happen. Get account would not have worked. So it's assumed that our account is account implements serializable. Okay, but look at what can happen now. The impression which is available, of course, in this account class also we got a deposit and withdraw method. So someone does something like this, he says, okay, let me get the account object and do something on this, let me invoke the deposit and withdraw method on the account object which I have received by using the get account method. Now what you've got here with the get account method, when this get account method is a remote method invocation, it is a pass by value. It's not the account object which is on the server, it's your own copy of that object. Making any changes here are not going to be reflected on the server. Oh, we don't have a pass by reference, is it? No, we can achieve pass by reference here also. Okay, how do we do that? Oh, just imagine on the role of the skeleton, what was it? It had to do the marshalling of the return value. It had marshaled the account object to the stub, and the stub was using that account object what is received. It has so the client is able to use that same the account object which has been marshaled, which had been unmarshaled by the stub and made available to the client. So that's a copy, yes. But just imagine that if the marshalling process which is happening here can, instead of asking it to create a new copy, if the marshalling can achieve a job of creating a stub for the account object. Oh, I'm talking about a stub for the account object? Yes. Here, account could be the remote type. If account is a remote type, that is, account is an interface where we've done identification. It's a remote interface having its own stub and skeleton, the way we have done the things for the bank. If we had done similar things for account as a remote interface, having an implementation class, having its own stub and skeleton generated, fine. And then if we have done this, okay, and if we use this method, the marshalling which is done is such that it would actually get a stub to the, it would result in, the unmarshalling on the stub side would result in the stub of the account being created and made available to the client, and not a copy of the client. So anything which is done on this is the account stub is going to be passed on to this via the stub to the skeleton of the account, and then to the actual account object on the server side. So yes, we can achieve something which is equivalent of a pass by reference. The stub here, fine, the stub here is our remote reference. We call it as a remote reference because anything you do on the stub is the thing which happens on the actual object. So it's possible always to create, it's always possible to have a pass by reference kind of things also using RMI. But for that, it's like primitives are always pass by value, which we knew. Reference types locally, they're almost equivalent of a pass by reference, fine. But when it is RMI, the reference types normally would be pass by value over RMI. But if it is, if the type is a remote type, and what we mean by remote type is nothing but the interface, remote interface, something which is extending the remote interface. If it is that type, and where all those steps have been taken care of, we have done the step of generating the stub skeleton things, fine. If that is the case, then we are achieving a pass by reference effectively here, fine. So fine, so this is about RMI. How do we achieve method invocation over a between a client and a server over a TCP/IP connection? Fine. Okay, so fine. In the next module, we should be looking at example where we achieve this RMI. Fine. Some example. There can be a very good example which we can try out, which is related to a. We can try out a chat server where we'll have objects on both sides. We'll have two kinds of remote objects. We'll have an object of a chat server, or object of a chat client, because in a chat server application there has to be communication between client and server both, fine. So we'll be looking at that in our next module, an example of how do we implement RMI. Okay.